Hi, I'm the tech support today, so in case you need anything, I'm here.
Great. I guess we will get started. It's 1 p.m. So, hey everyone, I'm here with Jon and Aji. My name's Ioana, and we're just going to walk through some basic SQL how-tos. Before we begin, I just wanted to mention if you weren't able to log into Metabase, if you can raise your hand so we can help you get that set up, just because we're going to be doing a lot of like practice problems to get familiar. So let Aji know if you need help with that. And also raise your hand if you have any other questions, if you can't hear me or if we're going too fast or too slow. I know that about half of you have done BCA2 and half of you haven't, so it's kind of a fine line to walk between those two levels of comfort. Okay, so going forward, I will let Jon and Aji introduce themselves really quickly, but you know me, my name is Ioana, and then before this, I used SQL at my work at Charles River Associates. It wasn't my primary program that we worked in, but whenever our data sets were too big, this is what we would switch to.
Oh, I guess I can go next. So yeah, I worked at Grab before as a something like a product manager. So I use SQL a lot to build my own dashboard so I can track my own metrics daily.
Okay, we'll pick up with Jon later. So our objectives here for what we want to help everyone get through is just get started with the basics, so a little bit of theory, just how to select variables, explore some data where we'll be doing some practice problems that you might encounter in your internship, and then we'll finally kick it off with some more advanced terminology and additional features. This is what the agenda will look like. I think we have you here for about an hour and a half, so we're hoping to get through all of this. We might kind of speed through the beginning just to leave more time for the end, understanding that for those of you that have done BCA2, you're already on familiar footing. So starting with some basic theory, the way that I would think of a database is an Excel file with a lot of tabs, and each tab represents information about a specific company or a specific problem, and there are certain columns within each tab that help them kind of speak to each other. And essentially what SQL is, it's one of these languages that can help these tabs talk to one another, so it's a bit more flexible than doing this entirely in Excel. I've written down kind of a pro-con list here. There's lots of pros. You can accommodate a lot of data. It's very simple to make updates, and it's also more secure. You don't risk entirely messing up your model the way that you could in Excel. I think the bigger con here is that it has a steeper learning curve, but once you use it, the syntax is pretty simple, and we hope that we can get you more comfortable. In terms of terminology, when we think of a sheet or like a tab in Excel, in SQL it's called a table, a column is a field, and a row is a record. A relational database is exactly what I described earlier. It's essentially a bunch of tables that connect to one another. I think the best example here is this idea of having orders, customers, and items. So when you think about keeping track of all of your orders, it's essentially a very long database that requires a lot of memory, and you don't necessarily need for every order information on where the customer is from, what's their phone number, what's their email, things like that. So that can kind of stay in a much shorter, condensed customer table. And all that exists in the order table is a kind of key that can connect you back to this customer table if you need that information. You probably won't if you're just looking at orders. So this order table would be like, okay, we sold 100 shoes in September. 10 of those were for customer X, and then you can go into the customer table, look at customer X, and see more information if needed. I will give a more concrete example with pictures. So when we talk about databases being related, they're related using these keys. So each table has its own primary key that's a unique ID to to that table itself. So in the top table, you'll see that agent code is the primary key because it's unique to the number of agents. Okay, Seema, reading out your question, how is SQL different than Power Query Python? I don't know Power Query. I know a tiny bit of Python. I think it's more database management as opposed to pure programming. I think it's harder to program in SQL if you're trying to do complicated econometrics. You'd probably use Python for that. But in terms of just managing, just keeping track of your customers or your orders, I think it's much more simpler, and it is probably, yeah, hopefully that's a solid point. Great. So for the agent table, agent code is the primary key because it's unique, and for the order table, you'll see that order number is the primary key because it's unique to that table. So the thing to note here is on the second table, you'll see that the agent code variable exists again. And so it's kind of the way you can map the agent table to the orders table. What we have here is kind of the way information is encoded in different variables. This isn't necessary to memorize, mostly just for your reference, but just to keep in mind, if something is labeled as a character string, so varchar, essentially if you kind of add it together, this is just like a possible syntax error you could be looking at later. If you add it together, like 1 plus 2, if these are coded as numerical inputs, it's going to read out 12, 1, 2 tacked on together. So always keep in mind if the variable you're looking at is a character, if it's a number, specifically if it's a number, is it an integer, is it a float, can it have decimals? There's a specific mask or variable type for dates. And variables can also be null. John will go into this later when we do joins, but if something doesn't exist once you're trying to connect to tables, then you'll get back a null. Next, we're going to move on to exploring data. And this is the syntax for the basic queries that we will explore together. Yes, we can send the deck out after the session. So what we'll do now is, if everyone has access to database, we'll just do a very simple question in Metabase, which is, we're going to try to figure out which 5 agents outside of London have the highest commission rate. So I'm going to share my internet. Great. Everyone can still see this? Yes? Cool. And hopefully everyone has access. So what we're going to do is we're going to click on Browse Data. We're going to click on Fuqua, and we're going to click on Agents. This is just so we can kind of look at what the agents tables look like. And essentially, we're trying to pick out which of these agent codes, which 5 of them, don't live in London and have the 5 highest commission rates sorted descending. So the way we do that is we click on Write SQL up here in the upper right corner, and we'll just kind of take it step by step in terms of the way I listed out the syntaxes that we're going to learn. So the first thing we'll do is we'll just select 2 variables. So that's just select, and you can kind of, once you, sorry, I'll just do that a tiny bit slower, but once you have your preferred syntax up here, you can actually just click tab and it'll write it for you. So we're going to select agent code and commission, and we're going to do that from the table that is called agents. Cool. And then we are going to click this button right here. And so now we can look at, these are the agents and these are their commission rates. The next thing that we're going to do here is we're going to select the agents that are not in London. So that's going to be where working area is not equal to London. No, I think it's lowercase London. Okay, so these are the agents that are not in London. Any questions so far? Pretty straightforward? Awesome. The next thing that we're gonna do now is let's order them by, we're gonna sort them by their commission rate. And we're going to sort descending so that we can see the highest to lowest commission rate. We only want the top 5 agents. So up here, we are going to write top 5. And what that does is it kind of limits the data to just these top 5 agents. And this works because we've already sorted descending. If we hadn't sorted descending, this would be a meaningless filter. And that is it. Oh, I have one more thing that will help for later once you're writing more complicated code. So we can use something called an alias, which is where we can rename variables just for our own internal code purposes. So let's say I thought commission was too long. I can just say commission as com. And what you'll see here when I redo the query, commission is shortened to com. And those are the 5 kind of basic syntaxes that we'll use like in this session, but just to get everyone more familiar with the code. So going back to the lesson plan, I was on slide, sorry. Yep, I was on this slide. Was everyone able to successfully pop out those 5 agents? Yeah, perfect, great. Then this is kind of just a breakdown of what that looks like. So we have these 5 syntaxes. In practice here, we have select, we have the alias, we have the limiting factor, we have the alias, we have the where condition, and we have the sort descending. From here, I'm going to hand it back over to Jon, who's going to do joins.
Awesome. Thanks, Ioana. Can everyone hear me okay? Cool. So I'm going to share my screen. And let's see. I'll share it on here. And then I'll also go into presenter mode. And I'm going to... Okay, great. So thanks, Ioana, for going over key and foreign keys and that syntax. That's really going to help us in our next section where we're going over joins. And so just to start off, let me come back here. Just to start off, wanted to talk about what are joins. And put really simply, joins are a way to merge 2 data sets. And so this can be really powerful within SQL just because being able to put together 2 data sets can actually help us surface increased information, help us to get new insights into our data. And so just to give a brief example, let's talk about this table that Ioana was just showing with agents. And if we just take this table by itself, we have our agents and their commission. But let's say I wanted to know how many customers each agent had. I wanted to know where those customers were located and how much they were paying. So that would actually be, that data is actually located in a different table, and that table is a customer table. So what I'd want to do is to join these data sets together to be able to derive new insights. And so that's done through joins within SQL. And it's done by using a common column that exists between these 2 tables. And so for this example, that common column is the agent code. And it kind of goes off of what Ioana was saying with the key and foreign keys. And this might be something that some of you who've taken BCA too are familiar with. And so, again, this is just an example of 2 separate tables. And then this is how it would look like once we join these 2 tables together. So the left 3 columns of this table come from that agent table that we originally had. And the right 3 columns come from the customer table that we're looking at. And I know I'm going through this pretty quickly, but I'll pull it up in Metabase so that we could do it together. But just to get through what the definition of a join is, I wanted to show this. And so, you know, by joining these two data sets, again, the whole purpose of doing joins is to be able to derive new insights. So now that I've joined the agent and the customer table, I now know that my agent, Mukesh, has 3 customers and that they're all in Mumbai. And then I know now that Alex has 2 customers, both of which are in the UK. And so again, the whole idea is being able to join data to be able to learn more about our agents. And so just going further into what a join is, I don't want to get too technical, but I like to think of joins as a duet of data sets. And one example is the song Shallow. I don't know if many of you have heard it before, but you know, you take the sweet baritone of a Bradley Cooper that has, you know, just enough of that Southern twang, and you combine it with the full operatic soprano of a Lady Gaga. And what you have here is that both of these people are bringing different data to the table, but they're singing the same song. And so that's how I like to think of joins within SQL. And once you hear this song, ironically, the song is titled Shallow, but what you actually get in the end result is something much, much deeper. And so that's what we're going to be doing today with joins. And so just really briefly, I want to go over the different types of joins that are within SQL. So for all my lefties out there that have grown up in a world made for right-handers, know that in SQL, the default join is a left join. So another win for my lefties. And what this basically means is that when we do a left join, we're going to keep all the rows from the left table, and then we're going to keep only the rows from the right table that have a match. And again, we'll go into an example to make it more concrete. But just showing other types of joins. There's a right join, which, you know, I usually just stick with the left join because it's much more simple, but you can join from the right where you keep all of the rows from the right table, and then you only keep the rows from the left table that match. Then there's a join called inner join, which only keeps the rows that exist in both of the tables, so only the rows that have a match, and then it takes away any other rows where there's not a match. And then you have an outer join where actually SQL keeps all of the rows from both tables, and for the rows where there's not a match, there'll just be null values in those columns where there's not a match, and we'll show an example of that as well. And again, I know that we went through those slides pretty quickly, but like Ioana said, we'll send them out so that for your own review. And so now I'll go into Metabase to jump through some examples. And so I'm here in Metabase. I'm just going to click here on Write SQL up here. And then just like the syntax that Ioana showed us, I'm going to do select, and then a pretty useful thing, let's say like you don't really know what's in your data set and you just want to take a quick look at your table, you can just do select star, and that gives you all of the columns in the table. And then for now, I'm just going to do from agents. So basically what I'm telling SQL is give, oh,
can you zoom in
go
your
ahead.
picture, John?
Oh yeah, sorry, yeah, that's really small. Okay, is that better?
Yes, thank you.
Cool. Yeah, so so select star is going to give me all the columns from the agents table. So I'm gonna go ahead and run this. I can either press this play button here, or you can press Control Enter. And then what we'll see here below, oh, let me back out of this for a second. Now what we have here is the entire table from the agents table. And you see here we have these 13 agents. I just, right here it's showing us 13 rows, so we know that there are 13 agents, but then also each agent has their own distinct code, so that's how you can also tell that there are 13. And so let's say that we wanted to do the example that we shared in the slides, we wanted to join this to the customer table. The way we do that, the syntax for that would be left join. Oh, sorry, I should write it properly. Left join. And then we do customer table. And so I'm telling SQL, give me all the columns from agents, join all the columns from customer, and then I need to tell SQL what the common column is, or what to join those tables on. So the syntax for that is just on, and then we'll do, and then we choose, so agents, the common column is going to be the agents code. So then we do agents dot agent code equals customer dot, oops, dot agent code. And so I'll zoom in on that real quick. So again, we do left join customer. We tell what columns to join on. And then we'll run this. And so what we see now is that we have our original agents table, but now we've joined all of the data from the customer table onto this agents table as well. And so one trick that I wanted to show really quickly, just like Ioana said, we could do, I guess we could rename these tables to make it easier to work with. So from here, I could do from agents and then just put A, left join customer C. And so what I'm telling SQL is that A represents my agents table, C represents my customer table, so that when I have to do the prefix here, instead of writing agents and customer, I can just write A and C. And this becomes helpful in a second, as we'll see, but we get the same result here. But this shorthand can be helpful as well, because we're looking here and we see all of these different columns. But this is pretty messy. I want to kind of clean it up. So I want to actually choose specific columns to keep. So what I'll do, oh, sorry, it looks like, let me see, we might have some questions in the chat. Oh, so we have a question about, are the commands always in the same order? We always start with select, and so yes, I'll just say yes, they're always in the same order. There might be a special case where they're not, but for our purposes, yeah, they're always in the same order. Good question. So coming back to here, so we have this table now with all of our agents data, all of our customer data. Let's say I wanted to see the payments that each agent is receiving. We know that we have information about our agents in the agent table, and then we have information about payments here in the customer table. So I'm just going to choose these specific columns. I'm going to choose the agent name, and payment. So to do that, I'll come up here to select. This is again where we select the columns. And then I'm going to do A dot agent code. That's one column. A dot agent name. That's another column. And then I'm going to do C dot payment amount. Because remember, this payment amount is coming from the customer table. So I'll zoom in on that real quick. A dot agent code, A dot agent name, C dot payment. And then we'll go ahead and run this. So now what I have is a table that shows me all my agents and the payments that they received from their individual customers. So as you see here, this doesn't summarize all the payment data because we haven't told SQL to do that. So right now, we just see 3 separate lines for Mukesh for his 3 separate customers and the corresponding payment amounts. So let's say that I wanted to summarize it. So to do that, I'd come to payment here and I'd write sum. And then anytime we summarize a column or sum a column, we have to tell it, we have to tell SQL what to group the data by, because otherwise, you know, we still have these 3 separate rows, but we're trying to sum those 3 separate amounts. So we have to add a group by statement here. And this just does exactly what it says. It groups the data. So I'm going to group by the agent code because I still want to see that. And then also group by the agent name. Zoom in on this real quick. Agent name, sum, payment. And then another thing we can do just for kind of aesthetics is, just like Ioana did in her example, we can rename this column to total payments. So we have a question. This is a really good question to say, what if we only group by one of these? So it'll throw an error in SQL because we're telling SQL to give us agent code and agent name. And then if we only choose to group by the agent code, then it doesn't know what to do with the agent name because there's no aggregation that's happening on the agent name. There's only an aggregation happening on the payment amount. And so you know, this actually might seem like more cumbersome to have these extra columns, but I like to include them because the agent code gives a distinct code and the agent name, but really we could just do one or the other and then just take it out of this select statement. But yeah, that's a good question. It throws an error if we try to do that. So I'll go ahead and run this to see what we have. I'll zoom back out. So now that we see this, we've totaled all the payments and we've ordered it, we've grouped by the agent code and the agent name. So now that we have this, what if we wanted to sort this column, total payments, so that we could see which agent had the most cells? So the way that we do that is just like Ioana showed, order by total payments, and then we'll do descending, and then I'll run this. And then by doing that, we see that Anderson had the most payments received, or tied with Santa Kumar. Great. And so I know went through that pretty quickly, but just wanted to kind of give a taste of the syntax with joins so that you guys could practice on your own in a second. We have a practice problem, but wanted to also, you know, this is all this data that we got, this aggregation to show the total payments. This is all possible by joining the agent and customer table. And so that's the purpose of doing the join. But let's say, you know, we're doing a left join, wanted to show really quickly some other types of joins. So I'm going to come back here, do select star. I'm just going to come back to my original agents table. So again, this is the original agents table. And I'm going to actually, I know that there's this, I'm kind of cheating, but I know that there's an agent that didn't have any orders. And so I'm going to do order by agent code descending just to show you who this agent is. So this agent here, A013, Sistine, this agent has been working from home and, you know, been slacking. You know, every time they should be doing sales, you know, they're just cruising Facebook or something. So I actually know that this agent doesn't have any orders. And the way that we could see that is by joining the orders table to this table and seeing if any orders come up. And so the way that I'll do that is by going, I'm going to delete this, and I'm going to do an inner join. So what the inner join does, again, if you remember from the slides, is it keeps everything from the left table and things from the right, or sorry, it keeps all the rows from both tables that have a match on it. So if Sistine doesn't have any cells, she's going to disappear from this table. She or he, I don't know the gender, so want to be careful about that. But so I'll do inner join orders. And then again, we want to tell SQL what column to join on. So I'm going to give a little nickname to these tables to keep track. So join on a.agent code equals o.agent code. So again, I'm just doing an inner join. It only keeps, when we do an inner join, it keeps the rows from both table where there's a match. And my theory is that cysteine doesn't have any cells. So if I do this inner join, that row should disappear. So I'm going to go ahead and run this. And so now it's joined. It's done the inner join. And then to be able to see if my theory is correct, I'm going to go ahead and order by agent code, because we know that cysteine's code is A013. So I'm going to go order by a.agent code descending. And sure enough, cysteine is not there in the data because there was no match, and inner join only keeps the matches. Let's say instead of doing an inner join, what if we did the other one we had here was an outer join, which keeps all rows from all tables. So that would look something like this. So I just come here and change the syntax to full outer join. I'm still going to order by this agent code. And then once I run this, it shows me, again, the full outer join keeps all rows, whether there's a match or not. And so we see here that cysteine comes back. And because they have no orders, all of the columns that are joined from the orders table are just left null. So and sometimes doing a full outer join, you could imagine the possibilities. Maybe, if you scale this up to hundreds or thousands of tables, we could see, hundreds of thousands of rows. We could see the usefulness of trying to track down which agents have no orders. So I'm going to stop there. Any questions so far about joins? Okay, great. So now I wanted to go into a problem exercise. So the exercise would be problem 1, which agent has the highest number of orders? And maybe we could just take like a couple minutes, and then if anyone is able to find out which agent has the highest number of orders, then you get prize, praise and glory forever. And then after that, we'll go over specifically how to go through that problem. So let's go ahead and take a minute. I'll just put a timer up here. And if any of you get the answer before the timer goes out, feel free to brag about it and put it in the chat on Zoom. I know Seema's on the verge right now. She's She's right there. She's about to get this. So I'll give a little hint if some of you are stuck. To find the highest number of orders, it's going to take joining the agent table and the orders table. We'll just give it another second. Is anyone on Metabase trying to do this? Maybe I just think that everyone's typing furiously on Metabase, but everyone's just waiting for me to go to the next slide.
I went to browse the data, but then I lost my code. So that was what happened.
By clicking on Write SQL, does that help? This top right button here.
Yeah, but then can you just go back and forth?
Oh, sorry. I thought it was just to get a clean slate. I don't know if it'll save what you had before.
Okay, yeah. So that's good to know.
Oh, nice. We got an answer in here. A002. Awesome. I actually, Sandeep, let's run through it really quickly, and then we'll see. We'll verify that answer. So just to go through it really quickly. Oh yeah, we got some other answers in here. Rahul put Mukesh, and we also got A010. So let's run through it. So the way that I would approach this is, select star. I'm going to just look at all the columns for now from agents. And then I'll do left join orders on. Then I'm going to do A here, O here. Then I'm going to do A dot agent code equals O dot agent code. And then let me just zoom in on this real quick. So again, I'm just doing a left join orders onto agents where agent code equals where the agent code matches. So I'll run this just to see the data that we have. And then, so on this order table, it depends on what column you're looking at. For me, I put order amount here. So if we do, so I'd want to keep the agent code column, maybe the agent name, and then give me also the order amount from the order table. And then I'll run this. So this gives me all of the orders from each individual order for the different agents, but we haven't summed up the order amount. So what we'd have to do next is actually sum the order amount and maybe rename this as total orders. And then to make it easier on us, we'll order by total orders descending. We'll run this. Oh, whoops. Agent code is invalid. Group by. Oh, I forgot to put a group by. This is just what we're talking about before. Is if you don't group it by anything, then SQL won't know what to do. So I'll go back here and do group by agent code and agent name. we'll go ahead and run it. And so Sam Baker put A010. Congrats, Sam Baker. Got the bragging rights from our SQL class for total orders. Yep, so, and then we have a question here. Does it matter if you do from order O left join agents A instead of how you have currently written it? So instead of having the left table be agents, having the left table be orders, I don't think that would be a problem as long as you aggregated it correctly. So, because what you basically have is, yeah, so maybe let's try that. Let's do that. So maybe we'll switch this around. Orders O, agents A, and then let's run this. Yep, you get the same result. It doesn't matter as long as you're summarizing the correct column, which in this example would be order amount, and you're grouping by the correct columns, which are agent code and agent name. So good question. Any other questions about this exercise? If not, I'll just show one last join before passing it over to Aji. There is another type of join called a union, which might be useful. I'm just going to go write new SQL, which might be useful in an internship. But basically a union is, it's kind of like you can think of if you have a table in Excel and then you have additional data for that table in a separate tab in Excel, and you just want to paste that separate tab into the first table that you have. So it's like adding two tables together. And it could be tricky because you want to just make sure that they have the same amount of columns within each table, and that and you want to make sure that you're matching the correct columns so that you don't you're not putting the bottom of a revenue column onto an orders quantity column or something like that. But union is another type of join that you can do in SQL. And then also another type of join that it gets a little bit more hairy is a cross join. And this basically is every possible combination of the two tables. SQL does it. This is just something to keep in your back pocket in case you come across a problem like that on your internship. If not, thank you guys for listening on this join section. I'll go ahead and pass it to Aji.
Thanks, Jon. Can you guys see my screen?
Yep.
Okay, cool. So yeah, we are going to talk about advanced queries and also how to make your queries like nice and production ready. So let's start with the advanced query first. First thing that I would like to talk is about the case when clause. So you can think of this like an if-then clause in other programming language or even in Excel. So it's just like a more sophisticated version of if-else. So you can use case in three places: select, order, and also at where. But it's not that useful, so we're gonna skip using case in where for this class. So below you can see the similarities of the syntax between those two functions. And let's just jump into the example now. Let's say we want to know which continent are our customers from. As you know, we don't have any column called continent right now, but we can just make that on our own. So let's say select. I'm gonna show you the customer table first. So you can see we only have country and city. We don't have continent, so we need to come up with that on our own. Now I'm gonna select only the column that I need. And we will add case to come up with the continent. Okay, then you need to specify else. So if the case clause cannot find the value that you want, then everything will just go to the else value. Let's put unknown here. And then you need to close the when clause and add a name to that. Okay, let's run this. So now you can see that this is the customer name, their city, their country, and then their continent. Because we didn't specify Australia, it marked as an unknown. Okay. So this is the result and also the query. Please stop me if you have any question. And next, let's take this one step further. We're gonna do case when clause on the ordered by clause. So for example, we want to know how much the customer pay or owe me, and I want it to be sorted by country. But for UK, I want to know who paid the most first. And for India, I want to know who owe me the least. So let's jump into the query editor now. Let's just delete these. Name. So we're gonna add the case when here. We're gonna end that first, and then we put the descending order here. Then we add the last order by here. So what the code is saying is that we select this column from the customer, and then for the ordering, we need to check each of the result. If it's UK, then we will order it by the payment amount. If the country is India, then we will order it by the outstanding amount. So if we take a look at the result, it will sort the data by the country first, descending. So UK is the first one, and then US. But for UK, as you can see, the payment is on the descending order. For the US, we don't care about the payment and the outstanding. So everything is a bit messy. But for India, the outstanding is ascending. So it starts from the least amount of outstanding first, and then all the way to the highest amount.
Hey, Aji, we got a question in the chat.
Sure.
Says, what does end mean in your code?
And so it's just to specify whether the case is already ended or not. So if you don't specify, then it's gonna throw an error. So the syntax for case is always case, and then like when, and the condition, then the result that you want, And like you multiply this several times, and then if you need else, you add else, and then you need to close it by n.
Got it. Because if you don't add n, then SQL will think that you still have additional criteria you want to put in the case statement.
Yes.
Yeah. Cool.
Okay, any other question for this part? So the next clause that I'm going to talk about is this thing. This is very straightforward. You can use this if you want to show only one result for every row. So if there's a duplicate, then SQL is going to just ignore it. For example, if you want to know in which city and country do my customer live, you can use select this thing for this. So let's do it right now. So SQL will only return the result once, Bangalore and India. So if we try to remove this, the result will be different. So there will be 2 entry of New York, USA, several entry of Mumbai, India. Let me order this so it's clear. If you add this thing, SQL will only grab one result for every same row. Okay, moving on, this is touching about what John has already mentioned before about the aggregation function, but I want to talk about several different functions as well. So you not only have sum, you also have count, average, min, max, standard deviation, variation, and etc. So basically, almost every function that Excel has, SQL also has that. And in order to understand aggregation more, I would like to touch about how SQL execute the order. So even though we write select first, so select is always on top on our query, but actually what happened under the hood is quite different. SQL will process from first, from and join, and then where, group by, and etc. This is the order of execution from the SQL engine. So this might look a bit weird now, but I promise you I will explain about this more later. So, oops, I forgot to hide the 13. So if we want to know how many agents do we have, we can just select count from the agents. So pretty straightforward query. So you get 13 because we have 13 agents right now. So, and then this is also the same that what John already mentioned, the group by. So you can categorize everything, all the aggregated result within a category that you want. So this is the example of the query. If you want to know how many customers do we have in each country, you can just select the country, count it, and then group by the country. Since John's already did this before, I'm just going to skip this for now. So let's take that one step further. So if you want to know how many grade 2 and above customer do we have in every different city, we can just simply add where into our query. So let's make it more interesting now. You can just simply use a where clause here. And don't forget to group it. So this is the result that you have. We only grab, we only count the number of customers that has grade higher than 1. So if you remove this clause, the result will be a bit different. See? So now let's make it a bit more interesting. If we want to know how many grade 2 and above customers do we have in a city with more than 1 grade 2 and above customers. In order to do this, we have 2 different levels of where. You can use a clause called having. You just need to add this at the bottom. So this is the number of city that has more than 1 customer with grade bigger than 1. So you can use where to filter your from, and then you can use having to filter your group by. This is like a 2-level filtering. Anyone has any question about this? Okay, so, whoops, there's a chat. Yes, grade is a table inside customer. That's correct, Nina. So if you're not sure what's the field are, you can just select star from the table that you want. Yes, so we have grade here. So count asterisk mean we count the number of row from the result. So this is showing 25 rows. If we count this, it will show 25. It's just it's quite similar to Excel's count function. Okay, so this is actually what happened under the hood when we executed this last query. So if you remember from the execution order, SQL will start from the from clause first. So SQL will grab the data from the from clause, which is the customer table, and then it will start working on the where clause. It's going to filter the data and remove customer with grade less or equal than 1. And then it will prepare the aggregated table. This is our final table, the result table. And then SQL will start to populate that table based on the grouping that we want. So for example, we know that this is Brisbane and Australia. So SQL will scan the data. If they found something that has similar city and country, it will do the count and then add 1 to here, and so on and so forth. And then the last part is Excel will do another filter. So this is the final table that we have after the where. SQL will do another filtering using having by removing the number of customer less or equal or less than 1. And this will be the final result that we have. And this is also one of the other example other than count and sum. You can use aggregation to know, like, for example, if you want to know when was the last time our customers made an order, we can simply use max for the order date to figure this out. So let's do it on Metabase now. I will show you the order table first. So as you can see, we have order date here, but we only want to know when's the last order a particular customer made. So we will use max in order to filter that out. Let's start with the customer code. We use max here because we want the latest date. And we'll do inner join. So now, because we have an aggregation here, we need to do a group by, and we need to group all the other column that we are not aggregating. So in this example, we will need to group it by customer code. And we will also need to group it by the customer name. So let's run it. So this is the last time Michael made an order. And this is when the last time Paul made an order, and etc. So that will be the end of the aggregation part. There are several stuff that I would like to mention as well. First is just to reiterate that you can use group by to categorize your aggregated result, and you can use having instead of where to filter your aggregated result. And this is quite important as well. You can only use asterisk with count. With other aggregation like max, sum, etc., you need to specify the column name. And when you use asterisk, count will count rows with null as well. So if there's an empty field or a null field, count will still count that field as the total count. But if you use count and a column name, so let me write it. So if it's like this, then it will count the null. If it's like this, this will not count the null. And since the other aggregation functions requires a column name, they will always ignore the nulls. So when you do a sum, when you do an average, if there's a null, it will ignore that. This is especially important if you're doing an average, because it will ignore the denominator as well. So you need to specify that the value is 0 instead of leaving it as a null or leaving it without the blank data. So before I move forward to the subquery, is there any question about aggregation? Okay, if not, then let's move on. So subquery is a nested query, so you can do a query of another query, if that makes sense. And you can use this in 3 different places as well. You can use it in the select, where, or the from clause. So for example, if we want to know who has lower commission rate than Anderson's, in order to solve this issue, we can do 2 different queries. First, we need to figure out how much does Anderson make every transaction, right? So we need to know Anderson's commission rate. Let's do this. So we know that Anderson's commission rate is 13%. Then you can use this information that we know right now to do another query. So we know now that these 5 people have had a less commission rate than Anderson. But the problem with this is that we are hard coding the condition. So for example, if Anderson receives a raise and his commission rate changes, then this data will be invalid and we need to fix the query, or even worse, we might make a bad decision because we have invalid information. So in order to prevent that, we can use a subquery to make our query become more dynamic and can keep up with the change. So this is how the query looks like. It might look confusing because there's a lot of select here, but I'm gonna write it with you guys so that we can understand it step by step. So let's do agent code. So instead of hard coding 13, we will check how big is Anderson's commission rate. We can do it by specifying this. So this will have the same result. But the beauty of this is if there's a change in Anderson's commission rate, our query will update automatically because we use this dynamic query here. So we know that the result of this query is going to be 13, but SQL will check it for us every time we run the query automatically. So any question before we move on to the other subquery? Okay, now let's say we want to know what was the biggest order that each agent ever made. So their biggest sales. We can use a subquery to solve this issue as well. Let me show you so this is the final code. Again, it might look a bit weird and complicated. So for this example, we are using subquery on the select clause. So there's a select within select. Okay, let's try and solve this in database. This. I messed this up. Let me try to fix this first. Oh, this one. So these are the maximum sales that its agents ever made. So we are selecting the agent code and the commission, and then we are doing this is like a cross join, and from those cross join we filter out where the agent code is equal the order agent code, and then we just get the max order, the max amount of that. So any question about this subquery? Is there a reason why you would use subquery over join? For this particular result, we can use a join as well, that's correct. But one particular reason why we might need to use a subquery if you want to aggregate another aggregate. Because in SQL, you cannot do, for example, average of a max. You cannot do this. You need to use a subquery. You need to get the average first. You need to get the max first from another query, and then use query that result again using the average. So for this particular reason, you are correct, Nina. We can just use a join, and it's going to be easier as well. Okay, let's move on then. So let's say we want to know how big of a contribution each agent made to our total sales. So we can use this subquery to figure that out. So the first thing that we want to do is we want to figure out the total sales. This is similar to what John did before. And then we will need to figure out the total sales that our company made, and then we will need to compare that to figure out the total contribution that each agent made towards the total sales. So let's write that into the database now. So this is a bit long, so I'm gonna read my cheat sheet. So I'm gonna keep everything there. I'm gonna start from here. So this will give us the total sales of each agent. And then let's do another one to determine the total contribution. So I'm gonna add a space here just to make it easier to read. It's the same again. So this is actually the very same query here, but then we're gonna divide this with the company's total sales. So we have another select. This is just the sum of all the orders that we have, meaning the total sales that the company have. And then we are going to multiply this by 100 just to make it easier to read. So it's as a percent. And then we will rename this as contribution. Let's try and run this. So now we know that Mukesh made a total of 12.7K in sales, and that equals to 17.49% of the total sales that the company had. So any question for this subquery? Okay, if not, then this is gonna be the last query that we're gonna do. What's next is just about readability and optimization, how to write the code so that it's nice, you can read it easily and you can show it to other people. So why do you need to care about this? Why do you need to tidy your code? The first reason is your future you will be very grateful. If, for example, next month or 2 months from now, you need to edit your code. If your code is a mess, then you will not be, or you'll be having a very bad time in editing that code. So just write it nicely now. The second reason is that someone will read your code. If you did a bad job, then you need someone's help. Then you need to show them your code. If you did a good job, then someone will want to read your code as an example. So either way, someone will definitely read your code eventually. And then the third one, you will write a better quality code, and it's going to be less buggy and it's going to be more accurate at the end of the day. So let's talk about readability first. There are several rule of thumbs that will help you write a better or more readable code. The first one is use large caps for keywords. So like select, count, from, where, use all large cap for that. And usually people use small caps for the other stuff. So I know that Metabase force us to use to write everything in large cap, but this is the normal, that's not the normal convention of SQL. Usually people will write it like this. Code. So we will only use all large cap for the keywords. For the table name, for the column name, everything is in small caps. And then try to start each line with a verb whenever it's possible. If not, then that's okay, because sometimes you need to start a line with and or with on, so that's fine. Add a space after commas, operators, and apostrophes. So for example, every comma, just add one space here instead of this. And then if you're comparing something, just use a space here. And then use a line spacing, meaning like pressing enter, usually after every verb. So try to make one line only have one verb. So don't do select and where or select and from in one line. So this is an example of bad code. So we have two different keyword and verb here. This is not a good thing to do. So just add a line spacing there. And also, if your line is too long, don't hesitate to break it into different lines. SQL will not care about the order of the line. So for example, if you have a very long line like this, and you have to scroll horizontally, that's not a good thing to do. It's gonna be very confusing. Just hit enter there and then add a tab. It's gonna be much cleaner that way. And the last thing is use indentation, meaning like hitting the tab key on your keyboard. Like I mentioned before, if you break the line because it's too long, make sure that the following line has more indentation. And for joins, usually people use an indentation as well. So from agents, something like this. And for subquery and case, usually people just use an indentation as well. So this is an example of the code using all of those rules that I mentioned before. So as you can see, this is the indentation after join and on, and etc. So that's another tips to tidy your code is to use in and between to tidy your operators. So instead of specifying the or 3 times and the and 2 times like this, you can write it like this, where agent names in blah, blah, blah. So everything is going to be executed in one line. And for and, you can use between. So this will make the code cleaner compared to this. So before we move on to optimization, any other question about readability? If not, then this is the last part. Maybe this is like the nerdiest part of this presentation. So why do you need to care about the optimization? First is to improve the performance of your query. We are only dealing with a very small data here, but imagine if you have millions and millions of rows, then you need to improve the speed of your query. Sometimes getting the result that you need can take 20, 30 minutes, or maybe even hours. So any optimization that you can do to your query will be very helpful. Okay, there's a chat. Is there a website you'd recommend to find keywords? Yes, there are several websites, but it mostly depends on what kind of SQL that you use. For example, MySQL and SQL Server is a bit different. So you can just Google that, and I think one of the resources that I use is called, yeah, so this one, W3 Schools, is a very good source for anything related to SQL database. So you can just browse around here and they have all of these keywords and documentation here. Okay, wait, another chat. Okay, thanks, Ned. So the second reason is because if your code is faster, then it will reduce the cost of running your query as well, because the cloud services like AWS, Google Cloud, and Azure, they bill by the minute. So the less amount of time that it requires for your code to run, the better it is. And the third one is to lower the risk of your query hogging the system, because usually when an SQL server is quite full, they will stop all the other operation until the last operation is finished. So if your code took a long time, then maybe someone will complain and like blame you for that. And this is just a simple chart of what do we need to do and care about optimizing our code. So essentially, there are 3 different processes for every SQL process, which happen in the CPU, in the system memory, the RAM, and also on the storage, the SSD or the hard drive. So this is just a simple comparison about their speed. So for example, if a CPU cycle, so one process of CPU takes 1 second, or RAM will take 4 minutes to finish that. And working on your SSD or your hard drive will take like 1.5 to 4 days to complete the same task. So we want to avoid working on our SSD as much as possible and keep everything at least in the RAM level. So in order to do that, there are 2 things that we can do. We can optimize the size, so we will only process a smaller amount of data. And then we will also need to be a bit mindful about how we are processing those data. So this is another thing that we need to know about optimizing SQL query. Also, SQL can work in two different ways. It can scan or it can seek the data. When an SQL scan, it will look at every row and every column of the data that we want. So scan means slow, while seek is like SQL has a map of index, so they can find the data that we need faster using the index. So bottom line is we want SQL to do seek most of the time instead of scan. And there are several things that we need to avoid to make this happen. So about the size, if possible, avoid select asterisk. We know that we did that quite often in this tutorial, and you might want to do this, especially if you don't know about the table schema. So you need to know what kind of what columns does a particular table has. So you might want to select asterisk that table. If you need to do that, please use limit or top, so that the SQL will only grab maybe like 1, 2, or 3 different results. So it's going to be much faster. So instead of select star from agents, just add limit 3. That's going to be very helpful. And then the next thing is about using join instead of where. So if you take a look at this query, both query will work fine. They will give you the same result. But this top query will process 408 data, while the bottom query will only process 34 different data. So you can use where to join the two different tables, but if you use where, then SQL will do a cross join. So, and as John mentioned before, cross join is like joining every possible combination, and that's going to be very bad. So try to use join properly. And then this is about optimizing the process. You should avoid using function on the left hand of comparison. So on this example, we want to know, we want to grab data from agent that their names start with RA. So on the top query, we process the left hand side. So we took the left 2 characters of the agent name. If it's RA, then return the result. But instead of doing that, we can do the operation on the right hand side of the operator. For this example, using like, so the left hand side is still the full data, agent's name, but we use the like operator, RA, and then a wildcard to grab the data of agent that the name start with RA. So the top query will do scan, the bottom query will do a seek, and the bottom query will be much faster. And still about like, do not use wildcard on the left hand side. So don't do a percentage sign or a percentage signs. Do not use percentage signs or underscore on the left hand side. Only use it at the end on the right hand side. And then the last thing is try to compare data with the same type. Ioana talked about this before. There are many different type of data. For example, order number in our data set is a float data type. You can write the top query using a quote. It will return the correct result, but SQL will do a scan because they need to convert the order number into a character data type because we are comparing with a character data type. And then the bottom one, since we are comparing both numbers, so SQL doesn't have to do anything, and then it will just do a simple seek, and the bottom query will be much faster. So yeah, I think that's the end of our presentation. If you guys have any other question, feel free to shoot it. I can stay for a bit longer. If not, then thank you very much for attending the presentation. I guess back to you, Ioana.
Thank you guys. That was amazing. even myself, that I kind of know some things about SQL, I was like remembering so much stuff. That was all.
Thanks for arranging this, Nat.